I'm Andy Howard. I'm the Innovation Programme and Smart Street Project Manager at Electricity North West. And today's presentation is about Smart Street Innovation Rollout Mechanism and what we're doing to support vulnerable customers in the North West. Smart Street was a low carbon network funded project from January 14 to April 2018. In the project we developed an awful lot of learning, some things that went well, some things that went poorly. Smart Street IRM is taking all the positives from that project to implement that proven technology and to integrate it with Electricity North West systems. The Smart Street project is targeting Electricity North West's vulnerable customers. And we're doing that to reduce their energy consumption. We're reducing the electricity losses on our network, both of which provide carbon benefits, and we're also creating capacity for new low carbon technologies to connect to our network. Smart Street is an element of Electricity North West's leading the North West to a zero carbon future. One of our strategies that, working with our stakeholders and various partners, we're looking towards pathways to a low carbon future. So how are we targeting vulnerable customers? Well, we're using lower level super output data for the North West to find the fuel pool, and we're targeting investment in substations in those particular areas, associated with other limits such as current uptake of LCTs and predicted future uptake of LCTs, and a number of technical constraints that we have in our selection process. The project is all about conservation of voltage management. It's about improving voltage control and management on our network, being able to optimise the voltage on the network to provide those energy benefits for our customers. Technically, what Smart Street is about: firstly, it's delivering 180 on-load tap changing transformers into our distribution substations. These are a mix of 11,000 and 6,600 kV transformers of mixed ratings, and they're all cable connected. These will be able to control the LV voltage by up to 20% around the nominal tap position. Standard transformers only allow us a 10% control. These tap changes will be allowed to tap on load, so we control on a regular basis what the output voltage for the LV network is. We are also meshing the LV network together. At up to 720 LV ways, we will be replacing the standard fuse with an LV circuit breaker. Those circuit breakers will be able to be remotely controlled and provide measurement data from the substation, such as voltage amps on the LV way. We will also be installing LV switches in remote link boxes that will be able to mesh these LV ways together. Finally, there's a communication and integration element. All these new devices will need to talk to our network management system, our control room systems, and then we will be implementing some optimization software within that control room system that will allow us to take the readings from site, model what the network is up to, what the optimum position should be, and then issue controls from the control room system to put that into place. So, in terms of progress, where are we up to? Well, for the transformers, we had to go through a review of our internal policies and a procurement exercise. But now all 180 transformers have been ordered, and the first one has been delivered to Electricity North West, ready for installation. Some of the challenges we face there is, yes, the actual policy and procedures to get those implemented, but also how we're actually going to integrate this new technology into our NMS system. In terms of the LV network meshing, again, we went through a policy and procurement exercise, and again, the LV circuit breaker element of that project is being delivered to date, ready for installation. Again, the issue we have at the moment is integrating that with our NMS system, but also some of the devices we're purchasing, we also use in the business in a slightly different way for quality of supply. So one of the challenges we have is integrating two systems to give combined benefits. Finally, in terms of the optimization software, our focus at the moment is ensuring that all the devices are going to fit. We'll talk to our control room system. We have, however, gone through the specifications for what we require for the optimization software and gone through a lot of the integration about how that will work with other key systems and processes. So in summary, where are we with the project? Generally, we're on track And indeed, a number of items in the project are going to be delivered earlier than anticipated in the IRM bid. We are about to commence the installation phase and get our first installations. So this is going to be a challenging time for us as we test that all the good planning that we put into place actually works. Although we envisage there will be some more learning that we'll need to embed in our policies and procedures and use to develop our training material so that these devices become a business as usual activity.